All right, we're finishing up what we talked about on Monday, which is going through equations of lines that are parallel and perpendicular. So remember that our parallel lines have the same slope, and our perpendicular lines, the slopes are opposite reciprocals. Opposite, change your sign, reciprocal, flip your fraction. So if I wanted opposite reciprocal of this one, this would turn into -2/5, would turn into, change your sign to a positive, flip the fraction, 2/5 becomes 5/2. So change your sign, flip your fraction for perpendicular. But here, we want parallel. So it's going to be even easier than that, because with parallel lines, our new slope is just going to stay the same. So it's still going to be -2/5. And now we're going to write our point slope form. Y minus the y coordinate equals our slope times x minus the x coordinate. So I'm going a little faster today because we're not doing anything different. I'm just doing a couple more examples to get you more comfortable with it. Y minus your y coordinate. Y coordinate here is 2. Equals our slope. Our slope stayed the same. It was a -2/5. Times x minus our x coordinate. Our x coordinate here is 5. So that's our x coordinate of the point. So now we're going to distribute our -2/5. So -2/5 times x. And then if I want -2/5 times 5 times a -5, well, first off, negative times a negative is going to be a positive. And then I have, this is 5/1. So the 5s are going to cancel here, and I'm just left with 2. So plus 2. So now to get y by itself, solve for y, I just need to get rid of subtracting by adding 2 to both sides. Y equals -2/5 x plus 4. So now we're going to graph both lines. So first off, -2/5 x plus 1. Let's graph that one first. The original line. So we're starting on our y-intercept of +1. And then our slope is a -2/5. That means change in y will be -2. Change in y being -2 means we're moving down 2. And then change in x of 5 means we're moving to the right 5. So down 2 and to the right 5, down 2 to the right 5, or up 2 to the left 5. 3, 4, 5. So that's our line. And then we have our y equals -2/5 x plus 4. Let's graph that line. And remember, the graph is just a way to double check our answer. We're still moving down 2 to the right 5. We should be looking for 2 things as we're double checking our answer. Number 1, this line should seem to be parallel to the original line. So it looks like it's going to continue on forever without intersecting with each other, without crossing paths with each other. That looks to be the case. And then the other thing we should check for is 5, 2. It needs to go through the point 5, 2, this new line. So we go to 1, 2, 3, 4, 5, and up to 1, 2, and hey, there we are. So one more thing to keep in mind here is that other than when we graphed the line and started our y-intercept here, this y-intercept doesn't get used at all. The one thing that people miss on this is that they think that, you know, there's a 1 here. We're using all the other numbers, so we must have to do something with this 1. But parallel and perpendicular just have to do with slope, because it matters how they intersect, or whether they intersect at all, not where. Y-intercept would control where, but we don't care about that. So we don't care about this +1. We don't do anything with it. The slope is what we care about, the -2/5. We're either going to keep the same, or we're going to do the opposite reciprocal. So we have one more example to do here. Remember, this week, we haven't done it in a while. So this week, you are turning your notes in for points. So I suggest that you do that very shortly here. So that you don't forget, and just make sure that you get that done. Because we've taken all the notes, we've done all the examples, so you should be able to just get them turned in. But we have one more example to do first. We're going to do one more perpendicular. Equation of the line passing through the point 3, 2 that is perpendicular to the line y equals -3x + 4. So I'm going to go ahead and graph my -3x + 4. And while I'm doing that, I want to see how far you can get in writing the equation here, so that you can try one and double check your work. Remember, you want opposite reciprocal for perpendicular. So give that a try while I graph the line. All right, here we go. New slope. We want it to be perpendicular. So this time we want to change it. We want to change the sign. So negative becomes a positive. Flip your fraction. So a 3 is that's going to be over 1. So -3/1 flips, becomes positive 1/3. So that's my slope. And then for our point, y minus the y coordinate here is 2. And then x minus my x coordinate here is 3. So we'll go ahead and distribute that. A third of 3, if I have 3 things and I get a third of them, then I get one of them. 1 out of the 3. So then all I need to do is to add 2 to both sides to get rid of the subtraction so that y is by itself. Again, we're solving for y so that it's easier to make a graph. -1 + 2 is 1. So y-intercept is up at +1. Slope is a +1/3. That means my change in y is 1, so we're moving up 1. Change in x is 3, so we're moving to the right 3. Up 1 to the right 3. Or down 1 to the left 3. Down 1 to the left 3. So we're checking for 2 things here. Number 1, we want it to be perpendicular. Remember, perpendicular makes right angles, so hopefully, without sounding too ridiculous, I can make a box there and say, yeah, that looks reasonable to be a 90-degree angle. If you need to turn the paper to look at it to see, oh yeah, right angle looks reasonable, then go ahead and do that. And then thing number two to be looking for is, I want it to go through this point. All right, moment of truth. 3, 2. All right, over x coordinate of 1, 2, 3. Come on, y coordinate of 1, 2. Yes! Got it. There's 3, 2. Beautifully sitting on the line. So we know we've done it right. So those are your notes. Your homework is 4 more of these. So the big thing to pay attention to. By the way, here's the symbol for parallel that we're going to be using. I'll talk more about that notation when we come back from break. That's your symbol for parallel. You already know the symbol for perpendicular. But pay attention to whether it says that the line is parallel or whether the line is perpendicular, because that's going to change what you do for your slope. But you're going to do the same thing that we were doing over here. Once you get the equations, you're going to put both lines on the graph, both lines, so that you can see whether they're parallel and perpendicular. Everything should work out nicely. We shouldn't have any messy fractions or anything like that. So all the problems should work out fairly nicely. You'll get some fractions for the slope, but when you distribute it and multiply it out, then everything should work out nicely.